So in first year chemistry, you learned how to write chemical reactions. So you learned about single replacement reactions, synthesis reactions, decomposition reactions, double replacement reactions. You learned about redox reactions versus acid-base reactions. And for this class, for the most part, instead of having to come up with your products, you'll normally be given your reaction. However, you are going to have to be able to predict what the net ionic reaction is. And the reason why is because the net ionic reaction actually shows you what is reacting, what is changing. Because when you create your net ionic reaction, what you are eliminating from the original reaction are your spectator ions. So those ions that have nothing to do with the reaction, they're just there, they spectate. So I'm going to show you really quickly how you can use these states of matter that are given to you in a chemical reaction in order to predict the net ionic equation, okay? And this can be for your synthesis, decomposition, double replacement, or single replacement reactions. So to start off really quickly, for states of matter, if I tell you that you have an aqueous compound, okay, what that means is that it is going to be dissolved in solution. So what you do with that is you actually break the ions apart, okay? If it says S for solid, that means that the particles or the ions are going to remain together. Okay? If it is a liquid, again, it's going to remain together, and if it is a gas, it's going to remain together. Now, there are a lot of solubility rules that you guys learned when you learned how to write double replacement reactions. However, the only solubility rules that you have to remember are that nitrates are always soluble, acetates are always soluble, and group 1 metals are always soluble. So whenever you have a compound with nitrate, acetate, or a group 1 metal, okay, those will always be soluble. They will be aqueous, so you will break them apart. Okay, so let's look at this example. So for that first example, you've got copper nitrate. So I know, even if I hadn't told you that it was aqueous, you would know that it was aqueous. Same thing for sodium phosphate. Since sodium is a group 1 metal, we automatically know that it is going to be soluble, and same for sodium nitrate. So honestly, I could have not given you any of those states of matter, and you could have written the net ionic. So I'm first going to break apart any compound that is aqueous or soluble. So copper nitrate is going to break apart. I have 3 copper ions, so 3 Cu2 pluses, because the charge of copper is 2 plus. And then I have a total of 6 nitrates, right? I have a total of 6 sodium ions, so notice I'm including the charge, being careful to include the charge. I have 2 phosphate ions, okay? My copper phosphate is going to stay together because it's a solid, it's insoluble. I have 6 sodium ions, and I have 6 nitrate ions. So now I can get rid of my spectator ions, or the ions that remain the same, that are unchanged or uninvolved in the reaction. So nitrate and sodium are my spectator ions. So my net ionic equation now is going to be 3 copper ions react with 2 phosphate ions to produce copper 2 phosphate. Okay, let's look at another one. So for example 2, it tells me I have chlorine gas reacting with aqueous potassium bromide to produce aqueous potassium chloride and bromine gas. So the gases, you're going to leave it as it is, so it's going to stay Cl2. Okay. I'm going to break apart potassium bromide, so I have 2 potassium ions, 2 bromide ions, and that's going to produce 2 potassium ions, 2 chloride ions, and then Br2. So stuff that stays the same, well, the only thing that is a spectator ion here is potassium. So I've got Cl2 reacting with bromide to form chloride ions and bromide ions. Okay, and that's it.